This is the video lesson for Mod 3, Lesson 3, Dividing and Rationalizing Radicals. So in this video, we're going to look at dividing radicals and rationalizing radicals, and what does it mean to rationalize. So when we're working with radicals, we're going to find some properties that are similar to how we would normally divide integers or whole numbers. There's certain things we have to take into account when we're dividing radicals. So this first set of problems is just kind of reviewing some things we know and some things that might be a little new. So obviously if I'm doing 6 divided by 3, right, that's just the same as 2, nothing too special here. When we're dividing radicals, though, if two radicals are getting divided, we can use what's called the quotient property. And so the square root of 6 over the square root of 2, if they're both under a radical, I could put them under the same radical. And that's actually the same as the square root of 6 over 2 or the square root of 3. The third problem looks really similar, but it's actually kind of different. Root 6 over 2, since they're not both under a radical, this is as far as we can go, right? Because 6 and root 6 are different, and that 2 is not under a radical. So our answer for that third one would just stay as it is, root 6 over 2. For the fourth one, anything in a radical can divide something in a radical. Whatever's outside can divide each other. So the 12 and the 2 are both outside the radical. They can divide, but the 6 can't really do anything, that radical 6. So the radical 6 stays there. 12 over 2 is 6. So our answer for that third one would be 6 root 6. And then the last problem, 12 radical 6 over radical 2. If they're both in a radical, they can divide. And we'll actually learn that there's actually a couple ways we can do this problem, but we can put them under the same radical, and we'll get 12 radical 3. The next part is a couple rules that we already know with radicals, and then a few ones that are going to get added on when we talk about division. So the first one is that you're not allowed to have any perfect squares under the radical, and that's something we saw already earlier in the mod. So if I have like the square root of 75, I know that a perfect square goes into 75. It's actually 25. And times 3. So 3 is not a perfect square, but it gets its own radical. And so we'd have to simplify root 75 to 5 radical 3. Some rules that are a little bit new now that we're doing dividing are especially number 2 and 3 and 4. So we're not allowed to have fractions under a radical, and specifically the entire fraction. It actually ties really closely to number 3. So 2 and 3 are kind of the same. And the big thing is we're not allowed to have any radicals in the denominator or the bottom part of a fraction. So you can see rule 2 actually breaks rule 3. They're kind of the same rule. So I'm not allowed to have any radicals in the bottom part of a fraction. So for like number 2, I'd have to take the square root of the top and the bottom. So the square root of the fraction, this is what's called the quotient property, that if I have a fraction with a square root, it's the same as the square root of the top and the bottom. And so when I look at the top part, I still have radical 3. On the bottom, the square root of 4 is 2. So we would write this as radical 3 over 2. For number 3, again, kind of goes with number 2. We can't have any radicals in the bottom part. And so what we do to kind of undo that process is we multiply the radical on the bottom by itself. And really we're kind of using the product property here, because what happens is if I multiply two radicals, I could put the numbers under the radical under the same radical. And on top I'll get 2 radical 3. 3 times 3 is 9. and the square root of 9 is 3. So what we did is we call that rationalizing the denominator. I turned the denominator into a rational number. So if you multiply a radical by itself, it gets rid of the radical that's in the denominator or the bottom part of the fraction. And then now we have a rational number or an integer or whole number that's at the bottom. And then the last rule we have here is you have to reduce. So for example, I can reduce this 8 over 2 to make 4 root 5. So if it's outside the radical, you can divide them. If they're inside, you can divide them, kind of like we saw in the earlier problems. All right, so for the first example, we're going to, again, kind of look at our perfect squares if we need to. But really, if I take the square root of a fraction, that's the same as taking the square root of the top part, or the numerator, and the bottom part, or the denominator. The square root of 9 is 3. The square root of 8 I'm going to leave for right now. But the square root of 8 can actually get simplified a little bit further. The square root of 8 does have a perfect square that goes in there. It's actually 4 times 2. And then the square root of 4 is 2. So that radical it got evaluated, so it went away. So we have 2 radical 2 over 3. And then we always want to make sure we look at, if I cover up this, cover up that radical, can I simplify 2/3? I can't, so this is my final answer. The same for question number 2. So I'm taking the square root of a fraction. It's the same as the top or numerator over the square root of the denominator. X squared is a perfect square, so it's like a little 2 here. So the square root of x squared is just x. And I have the square root of 18. And then you have to check if you can simplify. Is there a perfect square that goes into 18? There is. It's 9. And then so 9 times 2 is 18. And then we get 3 radical 2. And the bottom would be x. All right, for question number 4, it's very similar. So this is an example though where the bottom or the denominator is not a perfect square, so we might have to rationalize. So when we rationalize this out, the square root of 2/3, that's the same as the square root of 2 over the square root of 3. And then we can't simplify the square root of 2. We can't simplify the square root of 3. But we can't have any radicals in the bottom part of a fraction. So this radical 3 I have to get rid of. So we're going to multiply the top and bottom by radical 3. And now the top part, these are both radicals. So this is the same as the square root of 2 times 3. Under the same radical, this is 3 times 3. So we get radical 6 over radical 9. And then the square root of 9, that is a perfect square. So root 6 over 3, and that's as far as we can go. For number 5, same idea. So I have root 5 over root 7. That's as far as we can go to simplify, but we do have to rationalize. And so we get square root of 5 times 7, square root of 7 times 7. So the square root of 49 over root 35. So root 35 over 7. And that's as far as we can go. For 7 and 8, it's very similar. So we have 2 over radical 7. There's no fraction. We can't simplify root 7, but we do need to rationalize. We can't have any radicals in the bottom part. So I'm going to multiply by radical 7. I'm going to have 2 radical 7 on the top. 7 times 7 is 49. And the square root of 49 is 7. So our final answer would be 2 radical 7 over 7. And then finally for the last part, I have root 4 over radical 10. I have to rationalize. So we get 4 radical 10. And then this is over radical 100, which is 10. And then finally, we're going to look at our last, what's outside, because 2 sevenths for the last one didn't reduce, but 4 tenths does reduce to 2 fifths. But I'm not going to simplify that radical 10, because radical 10 and 10 are different. So our final answer would be 2 root 10 over 5. If you have any questions, you can sign up for T-Bolt time, get help in the center, or ask questions during class.